In this proposition, we're going to find the greatest common measurer of three numbers, a, b, and c, where no two are relatively prime to each other. First, let d be the greatest common measurer of a and b. If d also measures c, then it is the greatest common measure of the three numbers, because if otherwise, a number greater than d will be the greatest common measure. But the greatest common measurer of a, b, and c is also a measure of the greatest common measurer of a and b, which is d, which is impossible because it is greater than d. So, if d, being the greatest common measurer of a and b, also measures c, then it is the greatest common measurer of all three numbers. But if d does not measure c, we first recognize that d and c are not relatively prime. This is because we know some number measures a, b, and c, which will measure the greatest common measure of a and b, d, so it measures c and d. Therefore, let the greatest common measurer of c and d be e, and we will prove that it is also the greatest common measurer of a, b, and c. Since e measures d, it also measures a and b. Assume, by way of contradiction, that f is greater than e, and is the greatest common measurer of a, b, and c. F, by measuring a and b, also measure d, and also measures c, so it also measures e, which is less than it, a contradiction, so e is the greatest common measurer of a, b, and c. Thus, the way to find the greatest common measurer of any number of numbers, we find the greatest common measurer in successive pairs till we've done the whole algorithm for all numbers.